Number 14 was from complex numbers. So let us see how you go about it. So part A was from the locus part. So they gave us 3 modulus of equals to minus 6i. So they are start by let our z be in a form of complex number there. So we substitute here. So we have 3 real plus iy equals to x I y minus 6. After substituting, then I bring the imaginary parts together. Then here I brought the real part, x and negative x are the real parts. Then from definition of modulus, we say we square the real plus the square of the imaginary. So this will be now the square root of the square of the real part. Then still modulus square root of square of the imaginary, then square of the real. Don't include in the I because the imaginary is this, the real is that. We just square them. To remove the square root, we just square both sides. So when I square this side, I have 9. The square root goes. Square this. Then multiply. Okay, you can expand first. Equals to 36. Creating like terms, this is 9y minus 9x squared minus x squared. You get 8x squared plus 9y minus y squared, 8y squared. So this will be minus 36x. Then when I bring y that side, it becomes 12y. Then I have, this would be 36. So minus 36 is going to cancel the 36. So having no any constant equals to a 0. So from there, if you divide through by 8, x squared, y squared, by 8 will be having, I can reduce 36 over 8, I can reduce by 4 to get 9 over 2x. So still by 4 to get by 4 here, 3 by 4 into 8, that's equal to 0. Clearly, this is the equation of a circle with its center. Multiply the coefficient of x with negative a half, you get 9 over 4. Multiply the coefficient of y with negative a half, negative 3 out of 4. So you see clearly it's the center since the coefficient is the same here and the same here, and we don't have x and y terms in there. So that was part A, which we are. Okay. Then part B, find the square root of this. So our part B, there were 2 methods. You could use the algebra part of just letting this be a complex number, or we could use the modulus argument form. But the easiest part was to use the algebra part. So we said let plus or minus, or we can anyway plus or minus x plus iy be the square root of negative 5 plus 12i. So to remove the square root, I square both sides. Equals to now negative 5 plus 12i. Expanding this, get x squared. When I square this, I'll be having negative I'll be having I squared, which is negative 1 times y squared. So plus 2xyi equals to negative 5 plus 12i. Comparing, so x squared minus y squared will be equal to negative 5. Then when I compare this and this, okay, my 2xy will be equal to 12, implying that my xy is 6. So you can make x the subject, which will be 6 over y. But remember, I'm going to substitute this in there. So I need it as a square. So my x squared will be 36 over y squared. Then we come and we substitute it in that equation. So this will be now negative 5 multiplied by y squared. Have 36 y power 4 y squared. That equation will be now y power 4 plus 5y squared minus 36 equals to 0. You see that I can easily solve this, factorize it, factorize, you see if it's a quadratic. So we'll be having y squared, two numbers, the factors of 36, but when I add them I get negative 5. That would be 9, and a 4 equals to 0. So either this is 0 or that is 0. So when I equate this to 0, my y squared will be 9. So, but the 1 of y squared equals to negative 4. You see here we have no value because remember from here, always our x and y are real numbers. So there's no any real number you square and you get a negative. So meaning here we are going to be having, so it doesn't exist. So there's no any real number we can square and we get a negative. So we can't have that. So y here will be having plus or minus 3. So implying that when y is 3, x is what? When y is 3, x is 2. And when y is negative 3, x will be negative 2. So implying when I come back here, that the square root of negative 5 plus 12i will be plus or minus. I can take one pair, I can take this. So to get x, which is 2, plus y, which is 3. And so you get your 7 marks. Though you can also use the polar form by getting, first of all, the modulus of this complex number, then getting its argument, then substituting in there, get the 2 roots. You get the same answer. So either way, you'll be earning the marks. So, but this one was better and cheap.